So, good morning, everybody. Welcome once again to this exciting journey that we are going to be embarking upon, the journey of cloud computing uh, on the Google platform, essentially. We have with us the subject matter expert, the person who will be mentoring you, the guide who will be taking you through this exciting journey. All your queries would be answered at the end of the session. We've done this webinar earlier for the earlier batch also, and it is there on the website, and the links have been provided to all of you. They will be provided to all of you. You can also go onto our website and go onto the landing page and get all the necessary information regarding the batch, its curriculum, methodology, the scope of the entire course, what one needs to entail, the timings, the days, the payment gateways, any additional information that you would require. You could send us an email and a WhatsApp. Most of you all have been in touch by our counseling team who have been sending you information, relevant information, guiding you from time to time, leading you up to this webinar as such. But without further ado, I would invite uh, Mr. Ramakrishna Bhupati, who is currently will be interacting with you from California, USA. And he is the subject matter expert and who has tremendous insights in this. He would be the person who would be also conducting the course. And feel free at the end of the session to interact. Later on, as our practice has been, we also keep a doubts and difficulties session via a Zoom meeting, which also will be done. But please feel free to put your questions onto the chat. Our coordinators will guide you as to how you could be taking up the questions one by one at the end of the session. I shall join you again towards the end of this presentation and the webinar, essentially to take you through a brief roadmap as to first what Infinity EduServe and Consulting does, what is it that you can collaborate with us and benefit from the various offerings that we have. So over to you, Mr. Ramakrishna. All the best, and the audience is all yours. Thank you.
Hey, thank Swami. Let me share my screen first. I'm sharing my entire screen. So good morning, friends. My name is Ramakrishna, and today we're going to talk about cloud computing using Google Cloud Platform. Something about me, and I've been in the industry for more than 25 years, and I previously worked for AOL, Verity, Cisco, and HPE. And I've been working on cloud technologies since 2013, and my first foray into cloud technologies came out of my experience with HPE, where I was working on OpenStack. So OpenStack is an infrastructure as a service product, and if you want to install a private cloud on-prem or by yourself on your laptop, you can use that using OpenStack. So most of my experience comes from working in OpenStack. And I have bachelor's in computer science and engineering from JNTU. And subsequently, I also earned an MBA from Santa Clara University. And when I'm not doing technology, I'll be either hiking or watching movies. And I'm also a keen follower of tennis and soccer. Okay, so let's get to the agenda for today. So today we're going to talk about what is cloud. And then I will talk about the history and evolution of the cloud. We'll talk about public cloud and the market. We'll talk about virtualization. And virtualization is very important because that's what fueled cloud and the cloud technologies. And subsequently, we'll talk about containerization and Kubernetes. And then we'll take a peek into Google Cloud Services, followed by the demo and then the Q&A. Okay, sounds good? So, what exactly is cloud? I mean, you must have heard about cloud. When you're driving by, you must have seen advertisements on, IBM is on the cloud and so on. So, cloud computing is the use of hardware and software to deliver a service over a network. Now, when you say a network, it's typically the publicly connected, the internet. Now, how do you achieve cloud and how do you consume cloud? So that's the obvious question. And then there are several ways and means of getting to cloud, and one of them is using what we call as SaaS, which is software as a service. And then you also have access to what we call the PaaS, which is platform as a service. And then, of course, the important, very important, infrastructure as a service. So predominantly, when you think about cloud, it's most of it is about infrastructure as a service, because that's where you draw comparisons between hosting something on-prem versus hosting it on the cloud. Now, let's take a brief look at the history of the cloud. So, if you recall, mainframes have been there since 1960s, and in some way, you had mainframe located in some corner of the country, and then these are all accessible through network. But again, it was all internal private network from another place, and it was done using time sharing. And then 69, you had ARPANET, which kind of fueled the growth of network and networking technologies. And then in 1970, sort of, we had a primitive version of a virtualization software. And then in 1991, we have the web as we now know it. And then in 1997, a guy by name Ramnath Chelappa, for the first time, he defined cloud computing. That happened in 1997. And then in 1999, you had this Salesforce offering software as a service. That was the first time. Salesforce kind of popularized SaaS, if you look at it. And then between 1999 and 2006, VMware came up with the first hypervisor and virtualization as we now know it. And subsequently, Amazon launched EC2, and then we had a simple storage service being made available. And Amazon was using virtualization technology since then. And then since then, what happened is that Google started building cloud. Microsoft Azure started doing that. And then there's a host of other companies that came along. And now this market for cloud technologies, and then when you think about cloud technology, it's all across SaaS, PaaS, and then infrastructure as a service. It kind of exploded, and now it's crossing. I mean, in a couple of years, it's going to be $500 billion cloud spending. So that includes across the companies and then across the B2B and B2C. Now let's look at the cloud market. How are the big players? We have Amazon, which is by far the front leader, and we also have Microsoft Azure. And Amazon was a pioneer, and so it had Amazon had an edge over other companies. And then you have Google Cloud, and Google Cloud is actually the fastest growing. And then IBM has its own cloud offering, and same goes with Alibaba. And Salesforce is the dominant player in SaaS platform. And so is Oracle and Tencent, providing all kinds of cloud services. Now, why would some company move to the cloud? And what exactly fuels moving to the cloud? And why should you even, for that matter, would want to know about cloud and what are businesses doing? So there are several reasons, and then we'll go through one by one. And the first one is services on demand. What exactly means services on demand? Now, imagine your company hosting all its services on premises, on-prem. Now, I mean, a decade back, if you wanted a database service, you would put a request, and then your sysadmin or whoever would figure out what you need, and then he or she would set up a machine and then install a database service. Maybe it's Oracle, and then they give it to you. I mean, it's kind of it takes a couple of days. Now, think about other services. For example, your company now wants to monetize on the data it has. Now, it needs to do analytics. So, do you have the software on hand? Do you have it in house? Do you go and purchase it, or what would you do? So, essentially, it's about services on demand. I mean, whatever service you need, okay, it's probably already there on the cloud. So it's kind of compelling for you to go and try it out on the cloud, right? So services on demand. So services are available on demand, and it takes only a couple of minutes for you to sign up. Easy access and agility. So it's about how easily you can access it. All you need is a web browser and a laptop and an internet connection, and it's that's it. You're now on the cloud. You can access pretty much any service that you want. It could be Amazon or Google or Azure, whatever. Elasticity and auto scaling. Now this is a very big reason why companies would want to adopt cloud. Now, on-prem, imagine, I recall like 10 years back, Walmart, one of the biggest uh, superstore in the United States, during Christmas time, most of their servers went down. So, when there's something like a denial of service or a service not accessible, it means that immense lot of loss of business for the companies. So, but what was happening is that all of the servers were located on-prem, and then when the demand for services skyrocketed because people wanted to shop, people wanted to buy things on Christmas or the gifts or whatever, and the servers were not able to cope up with the demand. So, what would typically happen is that the staff would work overnight, install a couple of machines, set up everything, test it out, and then add it to the network. But then again, the next day, again for the New Year's Day, again the demand skyrocketed, and then it's not a viable option. You keep adding machines. But what cloud provides is, imagine all these resources are in the cloud, it automatically scale, because you sign up for a service that when we reach 60% utilization of CPU, then we need to spin off more nodes. So this is all automatic. You just let the cloud provider know that you need elasticity and auto scaling, and it's automatically provided. And it's not like it's now the default choice. So you automatically get it. And then you have cheaper and better. The resources are cheaper. Cheaper in the sense, what would be, how much it would cost for you in advance. And since these are resources are kind of paid by an hour or per day, so it gets cheaper in the long run, which also means better return on investment. Highly secure. So what does this mean, secure? Because if you look at where these resources are located, they're physically located in a very secure place, inaccessible to most. There's a multi-level physical security, and then there's a whole lot of logical security too. So you cannot I mean, even if you access those resources, you cannot use them, because it's encryption at rest. Especially with Google Cloud, any data that you store is encrypted as long as it's in the Google premises. Global network of resources. Now, if you look at what kind of resources that you have, I mean, these resources are spread out all around the world. Now, Amazon has got like close to 30 regions where they have resources, and recently they have set up resources in Africa too. So they have resources in all over Asia, Europe, Japan, South America, North America, pretty much everywhere. Easy backup and recovery. So when you have these resources or the data, for example, stored in the cloud, and it's easy to back up, and therefore it's easy to recover. So there's no loss of data. So imagine if there's a theft or a fire accident, it is all prevented, because the data is actually replicated 3 times in different regions around the world. So you never lose your data. High availability. So what does high availability actually mean? I mean, this is like very compelling reasons why companies go to cloud. Now, recall that a decade or so back, most of our email servers are located on-prem. And if you need to patch the services, I mean, there was a turnaround time. What that means is that sometime during the Sunday or Saturday, the sysadmins, pull up together and then send out a note that no mail server will be available during this time, and they fix things. And then they back up and come back up again later. But you don't have to do that now anymore, because your services, whatever that is available 24/7 without any interruption. And then, of course, the another critical thing from financial aspect is move from capex to opex. So most of the companies, I mean, if they want to invest in infrastructure, there's an upfront costs, and sometimes they're prohibitive, and then it makes it difficult for them to plan ahead, because they don't know how much demand their services would attract. So they would either buy excess capacity or sometimes fall short of the capacity. So, but when you go to operational, when you go to cloud, because it's elastic, you take advantage of it, and then you know how much it would cost. So you're converting your capex to operational expenses. So you can plan ahead. So you know that is going to incur so and so dollars per month, and so on. So that is good. I mean, everybody is excited now. They want to go to cloud, and your businesses are very happy. They want to adopt cloud. But then again, are there any challenges, or is it? Yeah, there are some challenges, but very, very minor. Security and privacy, and for example, a lot of government establishments, they want to keep the data in their control, which means they want the data to be on the machines which they control, on the machines they own, and so on. And for reasons, it's a question of developing trust. But I think when you think about it, it's only a matter of time that the security and privacy issues will just disappear. Okay. Now, on-prem to keep data secure. Some of the companies may have desire to keep the data on the premises, because they don't want the data to be hosted somewhere else. Very low latency requirements. Sometimes, because of very low latency requirements, you might want the infrastructure to be in-house. Okay, but that's changing. So now the cloud now offers very low latency provisioning. Government regulation, that's one reason why companies may be hesitant to go to cloud, because in some countries like Germany, so if there is any data that concerns their citizens, and it must be hosted within the country. So again, all cloud providers may not have data centers within every country, so that can be a problem. And again, portability and proprietary. So if you think about it, some of the systems, they may not be portable to cloud, because that's how the systems have been designed. So there may be a reason why they can't get into cloud. Now, we briefly touched upon the cloud service models. SaaS was the first one, and then you had PaaS, and then infrastructure as a service. So when you think about SaaS, it's mostly for the end users. Now, a good example of that would be, in fact, if you're taking this call, the StreamYard, I mean, this is actually a SaaS. So you pay a subscription, and then you use it. I mean, as long as you keep paying, you can get to use it, right? And it's normally targeted towards end users, like you, me, and then other. So similar examples are like Office 365, and then Slack, Gmail, and so on. And then you have platform as a service. Now, platform as a service, typically, a good example of that would be, I need a database. You need an Oracle database with some specific information. But then you don't care about on what machine or what operating system is hosting it, right? It's immaterial to you. All you need is a database. That would be an example of platform as a service. Now, other examples, you have OpenShift, Cloud Foundry. And then you have infrastructure as a service. So when you think of infrastructure as a service, primarily it's about compute, storage, and networking, predominantly because that's what everything else is built upon. And normally, the network architects, IT administrators deal with the infrastructure service. Normally, if you're a software engineer, you wouldn't be worried about infrastructure service because primarily it's handled by IT admin. Now, software service is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted, mostly dealt by end users and consumers. Now, we talked about briefly Salesforce, ServiceNow, and Gmail. They're all software as a service. Now, as we talked about before, platform as a service is a cloud computing model where a third-party provider delivers hardware and software tools to users over the internet. Mostly developers work in PaaS. So good examples are Red Hat OpenShift, Cloud Foundry, Google App Engine, VMware, Pivotal. Now, infrastructure as a service, which you may be familiar with, is it is service is a cloud computing service where enterprises rent or lease servers for compute network storage in the cloud. Mostly the network and the IT admins manage the resources. So primarily, when you go to AWS or GCP or Azure, what would you be looking for? Primarily, you need machines, right? Bunch of machines that meets your requirements, and then a network to put this together, and then create an isolated environment so nobody else would snoop into it. So that's pretty much what infrastructure as a service provides. Now, it's all nice. I mean, but something must have happened. Why, how cloud started emerging? Because I mean, 20 years back there was no cloud. I mean, that's kind of the sense what how we look at cloud right now. But something must have happened, so everybody started using cloud, right? Now, what exactly facilitated cloud? Now, one of the big things you keep hearing everywhere, virtualization. Now, virtualization becomes so heavily overloaded term. Now, there are various aspects of virtualization to it. Now, the big thing is, of course, hypervisors, which we refer to when we refer to compute resources, as in compute hypervisors, as in the virtual machines. Okay, so that is VMware kind of pioneered it, and then a lot of other companies contributed to it. So when you think about hypervisors, what exactly does it do to you? I mean, do to the hardware. So on the right side, you see this figure. You have hardware. Think of it as your computer typically, and you have your host OS. It could be Windows, or it could be your Linux, Ubuntu, whatever. And on that, you have these hypervisors. Hypervisor is a kind of an emulator, and what it does is it actually translates the calls from the guest OS onto the host OS. So the guest OS is running on the hypervisors, and each of them think that they own the resources. And the three guest machines, which we call the virtual machines, don't know about the existence of each other. So that's the kind of isolation that hypervisors provide. Now, the same thing happened, whatever has happened to compute has happened to storage also. So when you think of storage virtualization, it's also called software defined storage. Now, whenever you think about anything called software defined, then they're virtualizing everything. So that's what it means. So when you think of storage virtualization, what it means is you have storage, and it's highly tolerant and reliable. It offers multi redundancies, and it is fast. Now, that's precisely what you want, right? You want high speed access, and then virtually indestructible, which means you don't lose data. If one disk fails, right, the same data is actually, since it's replicated, so it's picked up from elsewhere. So that's think about how the technologies are moving into the future. Now, and then you have software defined networking. Now, what does it mean? I mean, now you have virtual switches and routers, and what is now happening is that a single switch or a router, a physical one, is now being is able to provide multiple networks. It was not possible before, and all this is because of, again, network virtualization. So in layman's terms, it actually it's like making the software do what was being done by hardware before. I think that's one way of looking at it. Now, with all this virtualization together, compute, storage, and networking together, now you can enable multi-tenancy. And this is where what fueled businesses to embrace virtualization and then being able to provide service on the cloud. Because without multi-tenancy, you cannot really have a cloud. The simple reason being, obviously, businesses coming into the cloud would want isolation, so that nobody else would share resources with you. Now, that's a big piece. Virtualization is what fueled uh, movement into the cloud. Just a second. So subsequently, what happened in the last 10 years, you had containers and Kubernetes came around. So when you think of containers, it's all about improving the utilization of your existing hardware. Now, what was being run on the virtual machine are now being run on containers. And then we'll talk briefly about containers in detail. And then you have cloud native. So what exactly is cloud native? So being able to move your applications from across clouds. So if your application is cloud native, you should be able to move your applications from across clouds, or public, private, or Amazon to Google, and vice versa. Now, to be cloud native, you got to adopt technologies that are obviously cloud native, certified cloud native. So as we talked about virtualization, it's about applications, hardware, and you have operating systems, and then you have applications. That is a traditional architecture. Now it is going towards hardware, and then you have virtualization layer. When you say virtualization layer, it could be hypervisor, or it could be network virtualization, or storage virtualization. And then you have the OS and the apps, and then apps that consume those resources. Now, we briefly talked about containers. And what are containers? So containers are lightweight, isolated operating system environments running on a host. Now, containers run very fast. Now, one thing that now you can see that what virtual machines are kind of dying, and then what containers taking their place. And in the cloud, changes are happening so fast that a lot of applications are getting containerized, and you must be hearing about it at work or elsewhere. So containers are actually lightweight processes. But again, if you think about a process, and we have had process for a long time, but what is different now is that now containers run in a very isolated environment. So one container doesn't know about the other running on the same host, and in fact, they don't even share the same resources. So that's a big deal. Now we'll see that why that is so. And containers are now replacing virtual machines, because now you don't need a hypervisor technically, because some of the container technologies have got merged into the operating system itself. Now, all containers on the node share the same OS. Now, this was different for virtual machines, because virtual machines had their own operating system. So containers are essentially processes that achieve strong isolation using kernel features, like the control groups and namespaces and network namespaces. Now, we don't have to go into detail about control groups and namespaces, but what helps containers run in isolation is these are the things that help containers run in isolation. Now, we talked about, touched upon Kubernetes. Why is Kubernetes getting popular? Now, when you have your applications getting containerized, then you need some orchestration platform to manage this. So, I mean, in the long term, what my belief is that Kubernetes as a platform will be like the operating system in the cloud. everything will run on containers, and everything is managed by Kubernetes. Much like open operating system manages the resources, so you'll have Kubernetes managing the containers. Okay, so Kubernetes is a open source container orchestration from Google. It automates computer application deployment, scaling, and management, and it's highly agile and extensible. And desired state versus current state. Now, what happens with Kubernetes is that you tell Kubernetes that I want this to be the desired state of the application. Okay, so I would say my application would need 6 containers, for example, right? And then Kubernetes will make sure that 6 containers are running. Now that might seem very simplistic, because what if another container dies or gets into an error state? So Kubernetes will automatically fix it for you. So you don't have to worry about whether your container is running or not, right? Now, if it repeatedly restarts or fails, then it's something that you need to fix. But otherwise, I mean, as we know that machines fail, nodes fail, and everything, right? Now, it's not the case anymore. So if if a container fails, then Kubernetes will bring it up. Horizontal and vertical scalability. So remember, we talked about scalability in the cloud. So Kubernetes. So if your application is running short of resources, then Kubernetes will automatically provide more resources. So it could be more resources for the container, or installing bringing up more containers. So it could do both. It could be that it could provide more resources to the existing container, or bring up more containers as is needed. Now, rolling updates with 0 downtime. So what does this really mean? So imagine if you're moving from one version of your application to another, what would you normally do? You would actually bring up another set of infrastructure and install version v2, and then bring up version v2, and then bring down the version v1, and then do the switchover. Now, all that is not required. Now, if you have like 3 pods, one pod will migrate to v2, and then slowly other pods will follow. Okay, so that's a rolling update, and there's no downtime for it. Automatic upgrades, so you can upgrade your pods, or even the nodes on which your pods containers run automatically. Now, when you think of containers, you also must be hearing about pods. I mean, this is, so we're not talking about pods here, but think that containers run in a pod. But right now, for our discussion, I'm using them interchangeably, although they're not they are different. But for now, let's assume that they are the same, for simplistic reason for our discussion. So you must have heard about the various types of cloud, and then one of the big cloud is one of the things, the public cloud, and then a public cloud is a multi-tenant platform. Now, you should remember that it's a multi-tenant. That's a big thing. That uses a standard cloud computing model to make resources, such as VMs, applications, or storage, available to users remotely. Public cloud services may be free or offered through a variety of subscription or on-demand pricing schemes, including pay-per-usage model. So a good example of public cloud, I mean, we're all aware, AWS, Google, Azure, and so on. Now, private cloud. So private cloud is a computing model that offers a proprietary environment dedicated to a single business entity or to a set of dedicated users. So private cloud is not for general public. Okay, so a good example would be you as a business entity would set up a private cloud within your premises. It could be on the prem, or it could be actually be at a dedicated data center. It doesn't matter, but it's public private cloud. Now, those of you who heard about OpenStack, so OpenStack is an open source software. It's actually a data center operating system. That's what they call it. it provides infrastructure as a service primarily. So you can use OpenStack and build your own private cloud. So hybrid cloud, what would be a hybrid cloud? So a mix of public and private cloud. So resources located both in public cloud as well as private cloud on-prem. Now the definition for hybrid cloud is kind of changing so fast. Now essentially it means that you have resources on-prem and on the public cloud, and then being able to move back and forth between the two. So pretty much you don't distinguish between the two. So that's what hybrid cloud actually means. So Google Anthos is one tool that provides hybrid cloud, and Red Hat advanced cluster management for Kubernetes are the good examples of that. Now let's look at the top 10 cloud providers. We have Amazon AWS, and we briefly looked at it, and it is the largest cloud provider, and it offers plenty of services. So as of last count, there are more than 200 services, very high penetration in the market, and Amazon generates close to 45 billion annual revenue for AWS. And then you have Azure from Microsoft. It is the second largest cloud provider, and Microsoft shot into, it started late but came up pretty fast because it capitalized on businesses with Windows installation, and pretty much Microsoft could go and tell the Windows customers, hey, you know what, we have cloud, come over. And I think that was a logical connection. So Microsoft took good advantage of that, and it's known for fast growth. And then Google Cloud. Google Cloud is the third largest provider, and GCP, as we know, is offered by Google, is a suite of cloud computing services that runs on the same infrastructure that Google internally uses for its own end products, such as Google Search and YouTube. Now, the focus of the presentation is predominantly on cloud technologies with a specific focus to Google Cloud. So along with GCP, and then there's a huge number of management tools that GCP provides, and a bunch of modular cloud services, including storage, analytics, and so on. Now, why am I pitching GCP? Because personally, I like Google Cloud Platform, and Google, although it was a late entrant, it made fast progress in the cloud technology space. And what if you look at the technology that GCP provides, right, they're the same technology that Google has used internally. And this may not be true with Amazon, definitely, because Amazon started off building up services. I mean, we don't know how much of it they use internally, but Google has built a lot of these technologies. I mean, in fact, Kubernetes actually came out of Google, and then Kubernetes is now the predominant platform everywhere in the cloud. And Google is the forefront of innovation. I mean, they do a whole lot of innovation. Google got the earliest implementation of SDN, software-defined networking. Now, if you look at the network virtualization as we know of today, and the greatest contribution came from Google. And again, just like Amazon and other cloud providers, Google platform services are available all around the world. Now, if you look at the Google Cloud Network Map, and this is Google's, in fact, this is the biggest network of any cloud providers, including Amazon. In fact, 50% of the network in the world right now travels on Google's network. So, okay, so I'm particularly here to pitch in to learn GCP. I mean, in fact, I'll be the one teaching the Google Cloud. And you might ask, why should we learn GCP? I mean, what's so special about it, right? Now, look at the demand for infrastructure services in the cloud is exploding. So what that means is that when infrastructure services are exploding. They obviously these companies will be needing people to manage those infrastructure services. So obviously, if it is Google Cloud infrastructure is exploding, they need Google Cloud skills, right? So which means it's an employment potential. There's huge employment potential, and there are a lot of companies waiting to move to cloud. Now, if you look at the latest industry data, only 30% of the companies intending to move to the cloud have actually moved, which means there's 70% of the company. There's so huge number of companies just waiting. Okay, so which means there's a huge potential for these cloud skills in the future. Again, there's huge empowerment potential for GCP skills. Huge demand for professionals with GCP certifications. Now we'll talk briefly about GCP certifications later, but there's a huge demand for it. GCP is expanding more services and expanding to more markets. Okay, and GCP certificates are highly valued. Now there are huge suite of products that Google offers. I mean, every day they keep adding new products and so on. So we'll briefly touch upon some of these. We'll not go into detail, but I'll show you where these products and services are hosted, so you can actually look at them. Okay, so Google Compute Engine lets you create and run virtual machines on Google infrastructure. I mean, what would you typically want? Either you want Kubernetes or virtual machine, and it's in simplest case you need a virtual machine, right? Everybody would be needing one. Okay, so that's what Google Compute Engine provides. The Compute Engine offers scale, performance, and value that allows you to easily launch large compute clusters on Google's infrastructure. So the scale of Compute Engine, like you can have virtual machines up to like 128 GB RAM, right? And then different types of machines, including GPUs, graphical processing units, which these days are really important if you want to run your AI or machine learning workloads. And again, there are no upfront investments, and you can run thousands of virtual CPUs on a system, and they're designed to be fast and offer strong and consistent performance. So the compute engine, so you get what? You get high scalable VMs, primary infrastructure service, and industry-leading price and performance. So for volume customers, I mean, Google provides discounts, and sometimes these discounts are automatically applied. I mean, like you rent a machine now, and then tomorrow that a discount is offered, right? It's kind of retroactively applied to your machine. Again, fast and efficient networking, and you have various custom machine types, Windows or Linux. Okay, so again, so we'll talk briefly about this. So Google Compute also has App Engine. So App Engine is actually provides platform as a service. So when you choose App Engine, you don't ask for a machine. You just take your application and run it, and then Google will take care of running it. And what happens if it runs short of resources? And no worries, it will automatically scale. So you don't have to worry about anything. And then the compute engine we briefly talked about, and Kubernetes, and this is a big piece because a lot of companies are now moving to containers. So obviously Kubernetes is the one that will manage all these containers. Cloud functions, when you think of microservices, you thought of cloud functions and cloud run. So they are like so you don't have to rent any machine here. Depending on the number of, you pay by the number of function calls that you process, these cloud functions and cloud run. So these cloud functions and cloud run, it's still in a nascent stage. It's really not many usages there as of now, so there's not much of discussion there. And then obviously when you think of cloud, you'll be thinking of, okay, do I have databases? Of course, yes, yeah. So you have Cloud SQL, which is the low end of our DBMS. And then you have it for MySQL and Postgres. And then for the high-end usage, you have something called Cloud Spanner, and this is Google's proprietary. It has got a very high QPS and very low latency, and it's high on ACID properties, and which is typically you expect a relational database management system to have be high on ACID properties. And again, this is Google proprietary. It's ideal for relational and structured and semi-structured data. And now we think of Cloud Spanner, you're talking about petabytes of data. Okay, so it's like 1,000 terabytes you're talking about. And again, you have Google Cloud Data Store, and this data store is a database, but it's not a relational database. So it's a highly scalable NoSQL document database. And again, it has got ACID transactions and SQL queries. And yeah, so there again, it's a Google's proprietary. And then you have Google BigTable. This is completely Google's proprietary. It's a wide column database similar to Hadoop's HBase or Cassandra. Now, these wide column databases are becoming very popular because it doesn't need any kind of schema. So these two are not RD relational databases. Okay. Now, what Google provides is a very high speed transaction, right? So we're talking about billions of rows and thousands of columns. Again, so there's one other very popular GCP product called BigQuery. Now, this is primarily for data warehousing or analytics. And again, here you don't pay by data, or you don't pay by number of servers or whatever. You pay by query. So how much data that query has processed. And the way Google handles this behind the scene is like, if there's more data, it'll add more servers in parallel. I mean, it's fairly sophisticated. So I don't think any of the other big providers have something similar to BigQuery. And in the industrial side, it competes with Teradata. So what I would think is, like, when you think about GCP, you would want to try it out and see what it provides. And I'll walk you through the sign-in page and then what you do. And then one good thing is Google gives you $300 credit. It's valid for 1 year to use the GCP resources. Now, $300 is pretty, good enough. So you can try and play around, right? Now, you sign up for it. You don't need a credit card number is required, but don't worry about it. It's not going to be used. Now, $300 is good credit, but if you run out of it, then create another Google account or Gmail, and then get another $300. So you can keep doing that. Okay. Now, I'll show you how to access GCP services in a second. So you can access from the console, or you can also access using Cloud Shell or the command line. Or if you want to install your SDK locally on your laptop and access the services, you can do that too. And here is one thing I want to highlight. If you join this course, we would be covering the first two: Associate Cloud Engineer. In fact, it's called Cloud Engineer, and then the Professional Cloud Architect. Now, there are other certifications, but primarily we'll be focusing on the first two. Now, why are we focusing on the first two? Is because they're the most generic, and then I've done those two myself, and I'm a Google Professional Cloud Architect. Now, I could also, and this course also covers a good chunk of the requirements for cloud developer, data engineer, DevOps, and machine learning. So we'll cover that too, because when think about any of these certifications, it's primarily GCP platform, which we'll go in depth. Okay. Now, one of the things that you might be thinking, like, what's the big deal? What should I take GCP certification? Now, if you look around, there's a whole lot of demand for GCP professionals. Now, nationwide, this is the numbers as of last year, what we got from ZipRecruiter last year. Sorry. So the national average around 135K. That is the average, but then it can go up to 194 for very skilled persons. Okay, so that's a demand for GCP certified professionals. Now, some of you might be thinking there's a whole lot of material on the web, and why can't you? I mean, I could learn it myself. And but think about the analogy thing about opportunity cost. Why should I do it? Why should I go for any of these trainings? Why can't I do it myself? But think about this. I mean, do you get the kind of guidance that you need? Now you can do it. All these technologies, learn it yourself. Because when I first started trying to do it myself, right, I took a long time. I took 1 year, and I haven't made much progress because I was kind of shooting all around, jumping from one technology to the other. So there's no consistency in my preparation. So what you would need is, and then one full year was wasted. Instead, what I did was I signed up for a training program, and in flat three months I could grasp everything because there was guidance from experts, and there was a clear cut path defined and shown. Now, without a clear cut path, what happens is you'll actually waste time. You'll be wasting time trying to do it yourself and not going anywhere. But then think about the opportunity cost. Do you want to do it now or do it 1 year later? But think about the amount of time you waste, and that time is money. So without guidance, right, I mean, nobody would dispute that you can do that yourself. But time, I mean, so save on time. So you'll be saving almost 1 year if you take this training program. It's compared to doing it by yourself, and 1 year is a huge amount of time. So think about the great things that you'll be doing. I mean, you'll be jumping into your new career path 1 year before, and what does that give you? I mean, these are all, that's how you actually measure, is this course worth for me? I mean, the way you figure it out is look at the opportunity cost. What happens if you don't take the training and you do that yourself? It can lead to a wastage of your time, and time is money. So we look at briefly a demo of this Google technologies, what we have. So let me go to so this is my personal account. So here, I mean, one interesting thing you see that I think only Google provides. Look at here, it shows the estimated charges, right? So I know how much I'm consuming. I don't have to wait for the billing at the end of the month to sometimes, you get a shock. Oh, did it cost so much? I never thought it expected it to cost so much. So it can actually gives you a figure of how much it would cost for me. Okay. So now typically what happens is, once you sign up, for the first time you sign up into Google Cloud and then open console.google.com, it'll come somewhere here. And then obviously you're expected to create a project, and then Google will prompt you to create a project, because without a project you're not going to be doing anything. So you create a project, and then you have, if you click here, here is where you'll find the plethora of services that Google offers. I mean, these will go on getting added. I mean, more services will be added. I mean, as you check out a couple of months later. Okay, so you have the marketplace where you can actually search for and install. Remember, we talked about high availability of services. Okay, so pretty much you can come here and search for services that you want. You think it may not be there, but the vendors are coming and then putting those making those applications available to you. Okay, you have billing and then API services. So we talked about how secure the API, how secure Google is. So you need to turn on the services what you want. So that even, let's say, somebody gets the key to your Google account, they still will need to sign up. So that's why it's very secure. So you need to explicitly sign up and sign into all those services. It support this IAM and admin. So essentially, it's about managing the identity and organization, like who can do what, right? And then here you have your Google Compute Engine, and then think about this App Engine we talked about, and then there's a Compute Engine. That's okay. Let's go back. Yeah, the Compute Engine, and then VM instance templates. This is like you create an instance template that is customized. Okay, sole tenant nodes. If you don't want to share the nodes with any other tenant, this is what you would be using. And then TPUs. TPUs are very similar to GPUs. Remember, we talked about GPUs, graphical processing units. So these are hardware chips. So you'll typically find them on these high-end computers. And if you're running games on your laptop, for example, right, you would be needing a GPU because for the fast acceleration. So TPUs are very similar, but again, this is Google's proprietary. And then there's a whole lot of health checks to make sure that your machines are running fine. Kubernetes engine, this is where you create, obviously you'll create clusters. Okay, and yeah, these are cloud functions, and Cloud Run are like it is called serverless technologies. It's just coming up. Now, all along you have been paying by using a machine on an hourly basis, but when it comes to cloud functions, Cloud Run, you pay by a number of functions exercised or number of requests processed. Okay, so these are all containerized. I mean, these are all run on containers. Again, you have storage. If you want to store data, that's what it is. And then, of course, database. We talked about databases. So you have all kinds of databases. And then networking. I think Google networking is one of the most advanced. I think none of these Microsoft or even AWS come very close to what Google provides as far as its networking capabilities. And now you have monitoring and logging, which is kind of vital. I mean, these days you want your application to be monitored, right? So that's what this will provide. Okay, I lost that. And then tools, cloud build. Obviously, at work you must be using POM, whatever tools that you use. I think it's project object model. I don't remember what it is. So, but then when you come to cloud, you have cloud build, cloud tasks, and so on, and container registry where you store your images. Okay, deployment manager, and then the big data. Okay, Hadoop Dataproc is very similar to Hadoop, and then publish, subscribe. Kafka, something like that. Data flow is a streaming Hadoop. Think of it as streaming Hadoop. BigQuery, we talked about BigQuery, which is a analytical platform. I mean, and then there are so many other products specific to verticals. And then the big piece, AI. AI. When we think of AI, everything is moving towards notebooks, endpoints, and then so on. Labeling. You can label your data. And I mean, there's plenty of there's Vision API, so you can actually detect a picture. I mean, take the picture of Taj Mahal and then show it to Google Vision. I'll tell you, this is Taj Mahal. I mean, we know it, some kind of stuff. And yeah, so this is. I mean, these are all. I mean, the kind of tools that Google provides for AI. I mean, no other cloud provider even comes very close to that. So Yeah, so that's concludes this presentation, and then we can now go into Q&A, and if there are any, so let's open the uh, session for Q&A. And how do we get this back?
Can we put on my screen now? Okay. So if so, everybody, I believe most of the queries would have been addressed over here by Mr. Ramkrishna, who is going to be a guide, like I said, and who would also be conducting this course for you. However, there's some more information that we would like to give you, is that yes, there would be one more doubts and difficulties session that we would be conducting just before the course starts on the 11th. So most probably on the 9th or 8th, most probably on the 10th, we would be taking the doubts and difficulties session, which we will be putting out onto the landing page onto our website. However, some more information as to what exactly is Infinity AD Server Consulting. Once again, my name is Professor V.M. Swami. I'm the founding director of Infinity AD Server Consulting. As you can see on your screen, we are a broad-based education service provider, right from undergraduate courses to PG courses. We have collaborated with NextGen Tech Ed for our IT and technology courses, which is being brought, this cloud computing course is being brought to you through NextGen Tech Ed. We are also associated with the UGC program via Venkateshwara Open University. So all the regular courses are also provided. And plus, at the core of it, we are essentially a finishing school into high level of skill gap evaluation and customizing courses, so that each of these courses are a value add to the people looking at 100% placement or enhanced placement assistance. So all our courses essentially lead to 100% placements. Uh, how do we do that? Right now, you are looking at a cloud computing course as a standalone IT course. But later on, we would be converging this course with different management programs. Essentially, it could be a certification program in management. It could be an EMBA. It could be a management development program. It could be a full-fledged MBA. Or if you are a graduate student and looking for a specialization kind of a graduation, then a BBA kind of a program converged with the various technologies. That is what we do. All our courses, apart from UGC and the different collaborators that we are also certified by the Ministry of Corporate Affairs, Government of India, Ministry of Micro, Small and Medium Enterprises, Government of India, Ministry of Commerce and Industry, and Department of Labor. So no matter in which gamut that you are seeking to be employed, at whatever levels, they're all covered, they are approved, and these are certified courses that we have. This very course on cloud computing is offered to you in two flavors. People in India, especially abroad, it is not looked at so much in terms of different kinds of value-added certifications, because this in itself is a skill set. But in India, we go out furthermore by doing a skill gap evaluation, and a certain parent community and the students look for a UGC kind of a value add. So it's in two flavors that you can do it standalone with Infinity and Next Gen Tech, as well as if you want to value add it with a UGC program, then you have a Venkateshwara Open University certification that you can opt for. Uh, Having said this, over a period of time, we would be putting up a lot of our courses that are coming up onto the website. Do visit them. Already, we are building up archives page in which you will see that we've already done an MBA data science, and the cloud computing, as well as the forthcoming other courses that we're doing, PSM, etc., would be put up on this page. You can get on to the payment gateways, which Ronak will take you through the entire landing page just now. He will also guide you as to how you could make the payments. And as we put up the Zoom meeting invite dates, we will intimate you via mail and WhatsApp, as we've been doing. We will also be calling you up. The counseling team will be calling you up to give you further information that you may need. I'll just hand it over to Ronak now. Ronak, could you just take over and send us through a guided tour?
Hello everyone. I'll just share my screen. So here we are. This is the homepage of the website. So you can reach out to the main cloud computing landing page where you can see the details of the course and register. So if you click on learn more, you will reach to the cloud computing page. Here, similarly, you have to register for the course. If you want to register, you have to click on the button or just fill up this form and find the details and everything. Once you fill up the details and click the button, you'll reach to the course module page. Here, you'll have the live webinars that have happened, all the live webinars that we have conducted and the query sessions we have conducted, you will find those. After that, you will see all the course modules also. So this is the webinar that is happening today. This is the query session that was happened earlier for the webinar. And this is the webinar that had happened on 28th November. After that, we have the course modules. So you can see all the course modules in a very brief manner and see what is being covered. After that, these are 3 free tests that are being given. So you have 3 options to choose from. Then something about why we are using cloud computing. I think the webinar has covered most of it. So we have 2 options of this certification. One is with the Venkateshwara Open University, Infinity and NextGen. And one is Venkateshwara and one is with Infinity and NextGen. So there are 2 fee structures. So you can click on the button fee structure. So here you have to fill up the form. And I think Swami sir will be more apt to let you know about the fees structure and other details.
So essentially, as discussed, it's in 2 flavors. One is Infinity and NextGen, which we feel that it should suffice. And that fee structure is 20,000 rupees for the course. However, if people are looking for a further value addition onto this from an Indian point of view, they need a UGC certification. That will be to the extent of 30,000 rupees. Plus, there would be some admission for registration and admission fees as such. So it would be in 2 flavors and in 2 offerings of 20,000 and 30,000, plus the admission fees, which you will get to know on that. Yeah.
So you'll have to fill up these forms to register for the course and have to select a specific test which you're looking for, register, then click on these links to do the payment. We also have the old-fashioned NEFT bank account details. So if anybody wants to do a NEFT to the current account, they can do via these details.
Is it possible, Ronak, to take them through one of the flavors of 20,000 or 30,000 when we click on Mr. Mojo?
So once you fill up this form, so you'll have to fill out your name here, let's say. So you put the mobile number. So you put your qualifications, let's say masters, working professional, free skill gap evaluation, and I do a register now. So we'll be receiving this. So after this has been done, you have to do the fee payment now. Click on pay now. So here you have to fill in your details, email, phone number, name, your address, and you click to proceed to pay.
Okay. So on the proceed to pay, the exact amount would come, right?
The exact amount is here, sir.
Where is that? It's 20,000. Yeah. Okay.
Since the 20,000 course is inclusive of the registration and admission fees, the person, anybody who wants to register has to pay the specific fees. So all the options, if they want to pay via UPI or they want to pay via debit card, they can proceed and get all the options to pay.
Fine, Ron. Can you just show them the previous Zoom meeting? Where did they appear? The Zoom doubts and difficulty session that we have taken.
Yes.
We'll be notifying one more session, or we would direct them to a recorded session already because it has been comprehensive.
This is today's webinar that is happening right now as we speak. And this is the earlier query session that had happened, the Zoom session we had. And
Okay.
before that, the live webinar which happened.
Okay. So when is the next Zoom session? It will be scheduled on the 10th. We will decide whether we can refer it to the previous one conducted and a link provided, or we could conduct a fresh one, because we believe that comprehensive questions have been taken. However, on that day, we will keep the fresh session open for about half an hour. Should there be people wanting further or different questions, we can take them up, or the link would suffice. Thank you, Ronak. Mr. Ramakrishna, would you say something towards concluding remarks?
Yeah. So, do you have any? Are you taking questions now? I mean, I can answer
No.
questions if there are any.
There are no
Okay,
specific questions right now.
Okay, that's fine. So those of you who want to learn cloud technologies or Google GCP, for example, it is a great opportunity because the demand for skills is skyrocketing. I think you take advantage of it, and you might think that, okay, I can do it myself. Yeah, I mean, nobody is going to stop you, but it will take a long time to doing that. But save on time, jump on the ship, and then let us do all the work for you. Okay. So I mean, when I tried to do this myself, I wasted a lot of time. Then I took guidance and then fixed it in 3 months. And you can do the same thing, and we are there to help you through the process. And we have designed a path. Just board the training program, and 3 months you learn all the skills. And if you want to do it yourself, you'll be wasting 1 year at least. And think about how you want to monetize your time, monetize your skills, and that's where that should be the motto, right? You don't want to waste time and to learn the skills at the earliest. I think so. Beyond that, I will let you do the thinking, and then come to a conclusion.
Right. Thank you very much, Mr. Ramakrishna, and I hope all of y'all have imbibed all the learnings that need to be taken into consideration. You'll give it a serious thought on this, a well-informed decision by all the platforms we are making available, because this is about career growth. This is about skilling. This is about excelling in your own fields. So embark upon this, like Mr. Ramakrishna has said, I wish you all the very best in your career quest. Thank you.